Okay, good morning, everyone. Oh, yes. All right. Welcome. Good morning, everyone. So you can begin to sign in on the attendance. We have that up already. So I trust that we're all doing great. We're ready for another exciting class. Okay, so we have the attendance link. And if you know anyone else that should be on this call now that isn't, please just let them know that the class has started. So we'll start 10. Right, we still have like 2 minutes. Let's start. Just we are getting excited. We are gradually rounding up with Python programming. We're gradually rounding up with Python programming. We'll be starting off with machine learning later this week, that's on Thursday. So if you are on this call and maybe you're just joining, please be sure to go over the last 6 videos now from previous sessions, and as well get ready for machine learning that starts on Thursday. So we're getting started with our machine learning here on Thursday. I think we should be excited, right? Yeah, I know a lot of people will be excited. So I think by Thursday, my colleagues will be taking that part. So you'll be seeing my face again. Well, I'll still be around, don't worry. So we're going to have another, I'll say stream now of learning. So as always, we'll still follow the same times, same processes, details will be communicated if any updates are required. So let's get started with today. Hopefully we have a good number of people joining now. Okay. Okay, let's see. Is it too late? If it starts and we've been trying to sign. Yeah, sign in. Please start signing in, start signing in. We can start signing in already. All the attendance, the registration. Yes, please. Let's do that. Okay, so let's start off. Last week we stopped at introduction to break and continue statements in Python, right? You don't have a student like, okay, so student IDs and the other details are on the info pack. Unless you just registered maybe 10, 15 minutes ago, is the only reason you might not have a student ID. So if you have registered, all you need to do is go to the info pack, look at the link for student IDs. Once you open that, you just search your name and you'll be able to find your ID. Okay. Good morning, good morning. Okay. So since people are still joining, all right. Okay, just a few more. Start right away. All right, so introduction to break and continue statement in Python. We initiated and we talked about for loops last week. We talked about how we can use the for loops to perform some blocks, some line of code iteratively over a list, strings, over an iterable, really, anything that we can iterate through. A series, an array, whatever we can iterate through. Tuples, your list, dictionaries, and all. So we talked about how that the for loop helps us to run the same block of code, the same instruction over every unit or over every item or over every object in that iterable. We talked about that. Okay. So today we'll talk about break and continue statements in Python. And basically what they are doing is break and continue statements help us to um, alter the normal flow of a loop, right? Normally, a loop should just keep running through some iterables, but there are sometimes you want to stop the loop at some point, or if there's a certain condition, you want to stop the loop without entirely stopping the whole code, right? So as we know, a loop iterates over a block of code until the test expression is false. However, we might want to maybe the current iteration, the current number we are on, and we don't want to check the test expression, or we don't even want to necessarily stop the code. We just want that to add a few, maybe other kinds of conditions or other types of instructions at certain times. So we use the break and the continue statements to do this. Let's look at some examples to better explain what we're talking about. The continue statement. Now, with the continue statement, we are able to alter the current iteration of the loop and continue with the next item. So I am in a for loop. The current iteration I am on now, I want to jump it, or I want to do something there, and I want to skip to the next iterable. What do you mean? Let's look at this list of fruits. Fruit list is mango, orange, apple, lemon, banana. We have a good number of fruits, right? You can type your list anywhere. I just want to display the whole thing without having to scroll left and right. That's why I click enter there. So now for fruit in fruits list, right? If the fruit is orange, continue. You see that under the if condition, we have an indent here, right? So there's an indent, and then back now under the for loop block, the indent for print is there. So that means print fruit for every time we iterate through fruit list. So who wants to give us an idea of what this is going to print? It will print every fruit, right? But when we get to mango, when we get to orange, something's going to happen. So let's take a look. All right. Okay, so for fruit, all right, here we are. You observe that orange is not printed. You observe that orange is not printed. Although orange should be printed second, it's not printed at all. That's because the continue statement takes this condition, and once it finds this condition is true, that is, if we've gotten to the fruit that is called orange, stop that iteration. Don't continue beyond that item, stop that iteration where it is, right? So don't execute this. Then move to the next iterable, which is now Apple, then continue to run till the end. All continue does is it initiates like a break in that for loop. And in the current iteration that meets the condition, it's going to ignore the code that comes after continue for that one in that for loop. Is that clear? So in that for loop, it will ignore, for example, if we have, okay, we'll use numbers. I think numbers better illustrate other conditions and they're easier to type. Or let's say, for example, if we had print continue as in past, right? Here we can say just before continue, because here we say let's print which all right, now when we print this, you observe that reach continue will only be printed how many times? How many times will reach continue be printed? Once when we reach continue, right? And you notice that this, although this will be printed for everybody else, once we get here, it will be printed. So continue has been passed mango, and because fruit is orange, reach continue is printed, and then as if nothing has happened, it just continues the normal iteration. So if we want to say, all right, now I want to do this thing as long as a condition is true, right? Or up until a certain point. I may not know exactly what it is, right? But I know that with the continue statement, I can initialize that break that is needed in my code. Let's look at some other examples. We want to print out all the scores, but we don't want the score that is 50 to be there. I want to print out all the scores of everybody in this class in the last quiz that had above 30. If it's not above 30, I don't want it to be printed. So let's say we have 20, 30, 40, 50, 60, 70, 80, 90, 95, 23, 5, 3, 6, 7. Okay, that's a lot. Now, for score in scores, if score is 50, continue. Otherwise, print, that is normal for loop. Print your score is, and print the score. If we print this, you see to print everything, but it won't print 50, right? Now, we can even change it such that if score is less than 50, continue. That means if you got into any score that is less than 50, ignore that score, ignore what you should run for the for loop, ignore the condition you should run, and continue to the next item. So that means any score that is less than 50 will not be printed. So we have all these scores that have been cut off. The same thing we can say if score is what? Greater than 50, continue. We will only have the scores that are less than 50 printed. So continue here also that you've reached the condition. If the condition is true, for that current iteration, stop what you are doing and move to the next item in that list or in that iterable. Now, the important thing here to note is that you can put all sorts of different things before you continue, but just know that after you continue, it will move to the next. It will totally ignore this guy for that iteration. Every other thing will be ignored. Okay, so let's look at another example. A farmer in Tigray region of Ethiopia wants to know the list of good eggs in his poultry. An egg is good if it weighs above 60 grams, right? Now use the for loop and continue statement to print out the good eggs. So we know what's the condition for an egg to be good? the weight must be above 60 grams. Now, if the egg is 60, is it good? If the egg weighs 60, is it good? No, it must be above 60. So it starts from 61. Right, but actually this one still allows that 60. So let's say if the egg is good, if it weighs 60 grams, and let's say and above, okay, so now this works out. So now for egg in egg weight, what do we say? Let's put this properly. If the egg is less than or, right? If the egg is less than or equal to 50, continue. That means if the egg is less than or equal to 50, don't print it. Because we have the print here. This is the print function. What we want to do, we want to print all the eggs, but we only want to print all the good eggs. So we need to not print the bad eggs. The bad eggs are which eggs? They are the eggs that weigh less than or they weigh 60. No, wait, hold on. Yeah, so if it weighs above 60 grams, sorry, this and above shouldn't be there. Because it's the bad eggs we don't want to print. So to do that, all we need to say is if the egg is less than or equal to 60, continue. If you've encountered an egg in this list and the weight of the egg is what? Less than or it's actually 60, ignore it and then continue to the next egg. If you meet the next egg, what? It's also less than or equal to 60. Do what? Ignore it, continue to the next egg. So we can look at it logically even before we print it. This is 59. It wants to do this loop. The first item it meets is 59. First egg in egg weight 59. Right? Is 59 less than or equal to 60? Yes. So it's going to continue. Ignore 59. Don't execute this print function. Ignore it and move on to the next one. 56. Is it? Ignore it as well. 61. Don't ignore it. Okay, print it. So by the time we print this, we're going to have what? Only 3 eggs are above 60. These are the good eggs. 61, 68, 69. I feel very bad for this farmer. So only 3 eggs made it through the condition, and they are the only ones that will be printed because this condition evaluates to false for them, right? Okay. So let's look at another example. For letter in code, if the letter if the letter is E, continue. Print current letter is letter, right? So what we are running for every item in the for loop is this print condition. But if the letter is E, ignore it. So how do we do that? By the time we run this code, you see that E will not be printed. If we say, even if we put plenty E's, it's printed that right after this E, if we were to put other characters, they will all be printed, but E will never be printed. Why? We've set up our condition and we've set up a continue. Is that clear? Okay, awesome. So let's look at an activity. We'll just do this for 5 minutes. Use the continue statement inside the for loop to skip the character from printing if the character is you in the string Kaduna. So this is I've already shown us the code exactly what it should look like. So I believe we can do that. So let's take a look. If the character is you in Kaduna, don't print it, but print out every other character. So as you are printing all the characters, only the character you should not be printed. I believe you should be able to do that. Okay, shouldn't take us too long. Maybe we should be done now. Right? Let's see. Okay, nothing in the chat. So it's really simple. All we have to say is what? For every element in Kaduna, if that element is what? You continue, that is, ignore it, move to the next one, and then print. Just make sure that we're printing other elements. And we'll get card now because you is, so you should get an output like this, right? How many of us got it? How many of us had an issue? You had an error? Okay, how many of us got it? Everybody's not putting their hands up. How many of us had an issue not getting it? Nobody's putting their hand up now. All right, so here's what it's supposed to look like. Okay, for val in Kaduna, if val is this. Okay, all right. So if the value is this, do that. Or we can also say we can say state is Kaduna. For I in state, if I is you, continue, print I, it's still the same thing, right? It's just variable names changing. Now, let's look at the break statement. Before I go to the break statement, is continue clear? Is the continue statement clear? All right. If you don't say it's not clear, I mean, I'll assume it's clear. Because I'm looking at faces and, well, nobody wants anything. You came late, so you have to go and watch the video, please. So we took like 4 or 5 examples, but basically I'm just going to go over it again, right? Let me see if any, I'm trying to see if someone says not yet. Okay, but I think we've taken 4 examples, we've looked through it. Please try it out, right? Try different things, try it out, and see how that goes. So I'll use this example again. The continuous statement is really simple. For whatever condition is true, right? For whatever, you just set up a condition. And when that condition is true in your for loop, that is when that condition is true in whatever value you are as you iterate through. Once that condition is true, what's going to happen is it is going to stop that iteration at that point it sees the continuous statement. For example, what do I mean? If we took this continuous statement and we put it, if we took the continuous statement out and we say print egg, print this, I don't say this times anymore. This egg is good. If rather than putting so I come here and I say print egg, and just after this if statement and we put the continue. Who can tell us what it's going to look like now? It will print everything. So it will print egg for everything. Look at it sequential, right? So it will go to for egg in this, it will print the egg. It will keep printing all, it will keep print all the eggs. Then so let's go through the code line by line. The first item in this list is 59. It will print 59. It will run this condition. If the egg is less than 0 to 60, continue. Right, then to print this egg is good. So what's going to happen is, unless it meets this condition, it will be printing this egg is good. So we will only see this egg is good after the good eggs, because we've changed where our continuous statement is, and we are printing this. So it will print egg. Normally print egg is good, but we initialize a condition that if the egg is bad, right, don't print this egg is good. Is that clear? Let's run it and see what it looks like. So you see, it prints 59, it prints 56. Right, but it will only print this egg is good after a condition, the ones that are greater than 60. So it's all about, so this egg is good only come 3 times because we only have 3 items that are greater than 60. So The important thing is whenever you initialize that condition and you put your continue statement, everything before it will run, and everything in that. What I wanted to show you this is whatever is in that current iteration, that one will run. But once it meets the continue statement, it's going to put the brakes on it and stop, and then move to the next item in the list or in the iterable and run from the top again. So I think that explains it. You can go through the video again for the other parts. Now, I think break is a lot. I'll say break is easier than continue. Break is much easier to understand. Break just breaks everything, right? Break is just, it's not slamming the brakes, it is ending the loop. That's the simple way. With the break statement, you can stop the loop before it has looped through all the items. A good example is we have a list of excuse me, let's look at a list of students, right? But we want to add up all the scores up until the total score, which is 1,000. So we want to know the sum of the scores up until 1,000. Let's say we want to know the sum of but we want to add up. So we have 10,000 students or something. They want to keep adding their scores until the total score reaches 1,000. So we need to set up a for loop, right? For this in all the scores, add the score, but stop once the total score is 1,000. So the break statement works beautifully there. All we need to say is if score is now 1,000, break. So let's look at how it works. So we have all these beautiful fruits in our fridge. I hope this is my fridge. This is definitely not, but this would look very nice in the fridge. Okay, so for fruits in fridge, right? Print the fruit. So we see there's no break. What's going to happen? It's going to print all the fruits, right? To keep printing the fruits, to keep printing the fruits. But once it gets to banana, it's going to stop the loop. All right. This code is going to print all the fruits, and once it gets to banana, all the fruits will be, and no other fruit will be printed, right? Please, if you have a question, please ask it on the chat so we can take it now. Okay. So here is the question now. How many fruits will be printed? How many fruits will be printed once we run this code? You know why it's still going to print banana? Because this comes before this and this is not continuous. So it's going because it's still the instruction is print fruit. So once it gets to banana, it will still first print banana before it runs this condition. If this condition came before this, of course, it will print it. So if the fruit is banana, we can change this to even orange, right? Once you printed orange, please stop my loop. So break will stop the whole loop, no matter where it is, no matter what it's done. It's like a condition to help us. Okay, I've got what I need. I don't need more computation. Stop. This thing may look trivial, but when you're really running, maybe you're creating maybe a website, you're doing your machine learning, and maybe you have like 100,000 computations you have to do, but you only need up to a certain place, and you don't need to run everything. All you need to do is you can, when you get to this point, break. In fact, there are many of these packages, of course, we might not see because most times we just run model selection or you just run something, but these are things that are run behind in the maybe up onto the fine code, because these days packages are built on top packages, right? So that's how the break function works really. Let's look at another example. Exit. So we want to exit the loop when the fruit is grape. All right, but this time the break function comes before the print function. Okay. Who has an idea why this thing keeps showing red? It's not properly indented. It will still run actually. You'll be surprised. It will, if the indents are, what's the word I'll use? If the indents are actually uniform, like spaces are uniform, it will run. It's showing red because it's not four spaces, it's not the convention. But as long as the indents are actually uniform, Python will take your indent and use it. But the convention is to use 4 spaces or just tab. I think it's 4. Yeah, yeah, 4, right? Yeah, it's 4 spaces. So we have this now. Okay, so we said for fruit in fridge, if fruit is banana, break, then print the fruit. Question now. Looking at this, how many fruits will be printed? You can see the answer already. 3. So, and why is it not printing banana this time? Because print function comes after the break. If print came before break, it will print banana before it encountered the break. All right. So, another activity. So, use the break statement inside the for loop to stop the program if the character is D in the string Ibadan. So, if the character is D in Ibadan, stop the loop. Now you can choose to put it anywhere, but once it gets to D, stop the loop. And let's do it such that D will not be printed. So let's print all the characters. And now, if the character is D, stop the loop. And do it such that D will not be printed. So that means your break should come before your print function. All right. Just give us 2-3 minutes for that. All right. All right. I think we should be done. So let's look at it together. What's it supposed to be? So we can say city is Ibadan, right? Or you can just use Ibadan directly. That's very faster. So I think I'll just rather use Ibadan directly. For character in string Ibadan. Now remember we said if, how did you say, we said if it's D, print break the loop, but we don't want D to be printed. So our condition must come before the print statement. So if character is D, break. Going back now, we step outside this indent, right? We're going back to the for loop indent and print character. So we're saying that's without, okay, let's run this first. So IBA, you get IBA, right? Beautiful. I'm glad we got a good number of yeses. So basically what we're really doing is, let's look at it. Imagine if we didn't have this whole thing here. If we did not have this whole thing here, what we are saying is for every character in the bottom, print that character. So it's going to run through and print. But what we really want to do is we want to stop it here. So I initialize, I just come in between here. And I say, you know what? Once the character is D, stop the loop. Is that simple? And okay now, so that's that, right? What if we change this to continue? If we change this to continue, what will be the result? Let's look at it. IB what? IBAAN. Any, is that the answer? IBAAN. Okay, someone is asking about the indents. As long as, and I explained this, as long as the indents are uniform, it's going to run. But for every block of a condition, a loop, a function, you have to indent. So Python is an indented programming language, so you have to indent it. Okay, so this is going to be IBAAN, yes, because the continue is here. So after the condition, rather than breaking the loop, it will stop and it will print D. It will move to the next item, print that item. All right. So now let's look through this one now. We have this list of numbers. It's very long. It's really long, right? But have no fear. You don't have to type all out. You can, or you can just use a range. I think rather we use the range. So numbers is range. What? Let's say range 1. Let's start from 1. Let's go to 10,000. That'll take a while. Let's go to 1,001. 1,001. Okay. So now we have 1,000 numbers. You know why we have to go to 1 at the end, right? You remember our range. Okay. So numbers is, so we have 1,000 numbers from, and numbers start from 1 to 1,000. 0 is not here, right? If we do this, then start from 0. Okay. So for now, the question is this: print out all even numbers from the numbers list in the same order that they are received. Now, because we didn't use the list that was there, we've printed out this one is just going to be normal, so we don't need to think about the order, right? And we don't want to print any numbers that come after 35. So basically, we are printing out all the even numbers before 35. We have numbers 1 to 1,000, and we want to print out what? All the even numbers. Let me delete this one. Let's start from the beginning. All the even numbers that come before 35. So what we want to print out is, let's look at it again. Let's be sure we all get the question. We want to print out all the even numbers in this list. And we don't want to print out any numbers that come after 35. That means the last even number we print is 34. All right, so we have our list numbers. What do we do next? So for number in number, this is actually quite confusing. No, there was this problem like this in the one of the quiz, in the last quiz, where the list was supposed to be numbers, but it was number that was left there. So usually in a case like this, I'd rather use something like num, right? Such that we don't now have to bother about making that mistake. So for num in numbers, that is every number, we want to say if the number, how do we check if it's an even number? What's a simple check? Modulus, right? Modulo 2 is what? Print the number, right? So now we move out of that if statement back under the for loop. So what this is just doing now is, if the number is an even number, remember the modulus will divide and return the remainder. So for an even number, the remainder when divided by 2 will always be 0. So that's why we're using this to check for even numbers. So print the number if it is even. So we already done that. Now, while you're printing the number, that's really awesome. That's great. But we don't want more than 35. So if the number now is greater than, right? Or all we need to actually say is if it's equal to 35, actually. So if the number is 35, once we've gotten to 35, break. We don't need to bother about 35 being printed because 35 is not an even number. So break, let's see, break, yeah. This should do. So let's see if we are correct. 2, 4, 6, 8, 10, 11, 12, 13, 14, 16, and we stop at 34. Yeah, so we're very correct. So in the same way, basically what we've just done is that simple. We said find the first condition. So like I said, when we have word problems like this, what we need to do is break the problem down into Python syntax, into conditions that you can check. So we have this, it says print out all even numbers from this list in the order that I received. So I know first of all, I need to find my even numbers. And to find the even numbers, we use this such that we understand that the modulo operator will always return the remainder when divided by whatever. So norm is what? Just iterating through the list of numbers, every number between 1 and 1000. All right. So that is that. So we have another list, a very long list. We use range again. Let's just say range. Start from 0 this time. Let's go to 100. Right. Okay. So it says print out all the even numbers. I think we can all do that. Right? Okay, great. So think we'll put a pause on the for loop there and go to the while loop. Now the while loop is one of the usually I think it's usually advised that if you don't need it, you don't need to use it because it can easily become a time loop, right? Like you have a time stone and you're caught in an endless loop, right? But it's reminding me of the last thing in this movie, Doctor Strange. But when we talk about the while loop, it's really very, very useful and it's going to repeatedly execute a single statement or group of statements as long as the condition being checked is true. So as long as the condition is true, it will keep executing that statement forever and forever and forever. If the condition doesn't stop being true, until your computer dies, it's going to keep running. So many times, I've written one of the most, I wrote a very, very complex one a while back that did a number of things, right? And that's one of the reasons why it's very good to do. I mean, this course is introductory, so we might not get too much into like object-oriented programming using classes and all those things. But it was so complex, so there were different conditions being checked and then being updated and all. And I had just forgotten, like it just skipped my mind. The last thing, like the last to update the condition to evaluate the condition being checked so that it will be changing. So sometimes it will be true, it will be false. So when it's false, stop the while loop. And I didn't, and while loop was just running at me, I thought everything was fine. So I left my computer, I went to sleep, I went to do other things. I just came back like maybe like 4 or 5 hours later that let me check my code that should give me my thing, and I realized that it has just been running. And that's what's going to happen. If it doesn't evaluate to false, it will just keep running. So let's look at how this beautiful while statement works. Have no fear while with your friend. Okay, so number is 1. While number is less than 10, print number. Now, let number be equal to number plus 1. Super important. Let me show you something. So while number is less than 10, print number, right? Let's forget that. Imagine, let's say this guy was in there. While number is less than 10, print number. We want to print a number as long as number is less than 10. We set up the condition, right? That while number is less than 10, you should print number. Who wants to give me an idea what happened when we run this code? Huh? Really? It just keep printing 1. It will keep, see this one is printing, it keep printing 1, like you see that, see this asterisk, it means the cell is running. If we go home, leave this laptop charge and come back next week, next Thursday, on Thursday, this is where we'll meet it. It will keep printing, it will just keep printing 1. If you want to make it fun, we can be clearing the output as we are printing, right? I think that's from Python. Not sure. Let me see if this will run. I want to and then see that. Not be sure model not function like that. What is it? No, it's a default. I want to clear the output so that we can count how many times it has actually printed. Okay. Okay, IPython.display. IPython. So imports clear out. Okay. So number is 1 again. One number is less than 10. So let me set up that n is 0. Print number. Print n plus 1. This code has run n plus 1. Right. Okay. And then clear. It's gonna be changing very fast. Normally, maybe I can put like 1 second delay or anything. If I put wait is true here, it still won't matter because this code will run very fast. But this is what I'm saying now. Check this out. Where times? Where did I put times? Oh, it should be a string. Sorry, it should be a string. So all right. So one number is my bad. See that? You see? So print. This should come here so that we can see something. Okay. This should come here. All right. Okay, this should go down. No. What's going on? Oh. All right, so clear the output. So print the number, clear the output, then print this. Okay. Next time, clear the output. Can you see that? And that's how many times it has printed n equals to 1, 1, 1, 1. And it's just going to keep. Now it's showing, it's running this fast to show you how fast Python is running. That's how fast. In a second, it can print it up to 300 times. There are some codes you can write that in a second it can print. In fact, in 10 minutes, you print it once. And when those are trained, maybe you train a deep. Okay, this is our first ML class. When you start training deep neural networks, one epoch could take 26 minutes, 30 minutes, 2 hours, and perhaps you want to run 50 epochs, you want to run 4 epochs, you want to run 10 epochs. That's 50 minutes times 10. That's 500 minutes. That's how long to take down the train. That's why you have to save your network. But don't worry, machine learning won't take that much time. But this will just show you how a while works. If we all go and come back, unless the computer has a memory error or something, it will keep running like this. It will just keep running like this. So that's why it's very important that we must find a way, because it's just printing number. Number is not being updated here. Number will always be 1. Do you get? We've set number here as 1. And we say, well, number is less than 10. Number will always be less than 10 because the value of number is what? 1. So we must find a way to make sure that number 1, the value 1 is increasing every time we run it. So all we need to do really is same thing I did here. Say number now be number plus 1. So what's going to happen now is once it run the code once, by the next time it's checking number will have been the previous number plus 1. So I've increased by 1. Normally you can just use this very short and n plus equal to 1 or number plus equal to 1. But just to make it, let us understand what we're actually saying, we'll use that. Just a minute. Let's see if we have any. It's clear output method. Yeah, clear output is call it a method from the an IPython display, right? It's for Jupyter notebook, really it's for Python interactive display. Okay, so all right, so now let's run this again. So let me stop this. Stop this now. Haha. Yeah, that's the other one. Okay. Does it stop? No. I might have to restart. That thing about you, I might have to restart the kernel, but that's not big deal. It's still running. Do you know this thing you are seeing on our computer now is not running. This is what is running. This, right? It's a local server on your computer. So what you are seeing here is the interpretations, let's say, of everything running like on that. So that's why if when you start, I'm sure many of us sometimes after we open, we'll close the Anaconda from and you see that to tell you that your notebook, to tell you that what kernel error or something. That's because you've actually closed the engine. So once we run this now, we should see that this code run has run 9 times. It will stop now because number is being updated. So print number. But we are clearing the output, so don't let's clear the output. All right, we're not clearing the output now. So print number 1, 2, 3, 4, 5, 6, 9. So our number is less than 10. So our code is stopping now because we set up a condition, right? And we are updating that condition. Another interesting one you can do is okay, we can see print number. This has set up an infinite loop, right? And because this condition will always be true, right? And this one will just keep going, just keep going, just keep going. So there's no condition. All we say is while true, right? And maybe you want to run something that you want to actually run forever. You can. I'm not sure. Well, there's some use cases for this actually, but this just to show us that the while loop will. Let me stop this one quickly before we run into trouble. Okay, let's just restart. So that is for the while loop. So the most important thing for the while loop is make sure you are updating your condition. Okay, there's something like this. Just make sure you are updating your condition, that's all. So let's make it a bit more interesting. Now you can combine for and while loops. You can combine the while loop and the for loop, right? Depending on your use case. All right, warning. You must remember to increase number, right? Like we've seen, or else the loop will continue forever. One unique feature about the while loop is that it requires relevant variables to be ready. In this example, we need to define an indexing variable number, which we set to 1. All right, so this is what I showed earlier, that we can actually also increment using just plus. So number plus equal to 1. We'll add 1 to every instance of number. This is the same thing as this. So these two, this guy and this guy are exactly the same. All right, so while number is less than 10, print number, right? It's not continuing forever now because we are incrementing number. Very, very important. So printing a number that is less than 20. A is 8. While A is less than 20, print, we're using the string format method, print the item A is less than 20, right? So now let A be what? Increased. A equals A plus 1. So 8 is less than 20, 19, and stops at when? 19. Okay. All right. So any questions so far? Any questions so far? Yep. Yes, you can install it as a module. So it's only here. I think it's a default Python variable. So it will run here, right? And it should run. If it doesn't run, then you might have to install. I don't think you should install it if you have Python installed. you should like come with your Python. So you can try it, it should run. I believe it should. Okay. Okay, someone says no, sir. Oh, okay. So maybe someone has tried it out, it's not running. Yeah. So if it's not running, I think you might be able to install it, and if you can't install it, maybe not. But because Jupyter Notebook is by default interactive Python, so it's, I know that is cool there. So any question, boss? Okay, no, sir, is the question. Okay, no question. Yeah, but does anyone have a question? Any other question? Okay, so no questions so far. All right, so let's move on. Okay, so we've done this. All right, so let's look at this again. Another example. Where is it printing? Okay, here. So we want to print a number that is less than 20, same thing. So we start by setting x as 0. So while x is less than 5, right? The usage should be less than 5 then. So while x is less than 5, so we're printing x is currently that number, right? Print x. And then let x be here, right? So it's then adding 1 to x. So add 1 to x every time. So you can also write x plus equals to 1. And remember that backslash is backslash, yes. Backslash n is to print a new line. So x is currently 0. Adding 1 to x, x is currently 1. Adding 1 to x again, x is currently 2. Adding 1 to x, x is currently 3. Adding 1 to x, x is currently 4. So with a while loop, you can do something like this. You see that there is no, we are incrementing number, but there's no list. We're not iterating through any list. We're not iterating through any tuple or any dictionary. But you can also combine a while loop and a for loop. I think we'll see an example of that later on. So there's a potential to write a condition that will always remain true. Like I said, that is, you have an infinite while loop. And unless you have a time stone, you cannot come out of that loop. So if this happens to you, you can stop or restart the kernel. And sometimes it might be difficult, especially in while loops, it might be a bit difficult to stop the kernel. So all you have to do is just restart kernel, yeah. All right, so the continue statement, you can also use your continue and break statements in while loop. Just as they work in for loops, let me see if I have any questions on Zoom. Just as they work in for loops, they work exactly the same in your while loops. Okay, no question. Okay, so let's look at this example. Let I be 0, right? And I increment I, but stop, right? Continue is coming after I is 4. That means don't print. So we're not going to print 4, right? So it's just the same as your for loop. See, 1, 2, 3, 4 is not printed. It continues to the next iterable. If we use break, what's going to happen? 1, 2, 3, stop. So your loop and your continue and break works just the same for your while loop as we have seen. So we've covered this. So we'll just move to the next. Okay. So now, general tips on your break and continue statements. Break is used to exit a for loop or a while loop, right? While your continue is used to skip the current block and return to the for or while statement. So summary of loops now. Basically, for a variable in any sequence, remember, you put your code or whatever, your if condition and your continue. It will continue inside the for loop. Whatever is outside that indent to continue outside the quote outside your for loop. So the indexing, so if I want to write codes that I want them to run inside my for loop, they must be indexed in the for loop. by the index. This is just, where is it? Okay, let me just put that here. Just to cover indent again, to make sure everybody's on the same page. For X, Y, Z in A, B, C. I'm not going to run this, so now Python, Jupyter Notebook will automatically indent for me. So everything here is under this for loop. Once I do this, these guys, the arms are not under the for loop. So if I put, maybe I do another indent, maybe another condition, right? And I move here, this guy is still under this for loop. So everything, as long as the index was right, it's going to keep running under the current iteration of that for loop. But once I step to the same level as this for loop now, it's no longer what? It's no longer under that for loop in that indent. So you find out as you write code, as you begin to, maybe I'm combining multiple if statements, else, elif, if you're combining that with the for loop, with the while loop, your indexing, you have to be really careful. And the thing about that indexing is sometimes you might not get an error because your indexing is correct, but you are not indexing it how you should. So you get a logical error where you're getting an answer, but the answer is not what you expect it should be. Okay. So while condition, yeah, if condition is true, condition continue. Yep. Yes, we've covered that. Okay. So the beautiful part, the one of the most useful parts that we all have to must and we have to learn is functions. We've seen functions like print, and you remember early on when we started, when I showed us a function, how to write your own function. So that's what we just want to explore in detail now. Python functions, how you can write your own functions to do things. Because imagine we want to write a code inside the for loop to compute. Remember when we did we wrote the code to compute the what's it called now? I think it was the area of rectangle, something like that with the loop. If we had to do that inside the for loop, the code gets very messy. I mean, to write the code to compute the area of a square or a rectangle is simple, it's just a times b. But if it's a problem to maybe find the area of the square, then using that square, find how many times you can fit that square in another rectangle, then do something, it becomes very long and it can get confusing that for. But you can write all that as a single function, and maybe 8, 9, 10 lines of code can become one line of code, so that your for loop is simple and it's easy to read and interact with. So Joshua, people, please, you can ask your question on the chat. So we'll just take it. So Python function is a block of organized and reusable code that is used to perform a single and related action. It's a piece of code that runs when it is called or referenced. Python provides many inbuilt functions like print, inbuilt type, length that we've all been using and we're having fun with. But it also gives freedom to create your own function. So you can have your user-defined function or your built-in function. Please do not use, as we said before, don't use Python keywords, right? Don't use a function name that is existing in Python already to create your own function. Because if you do that, Python will allow you. But if you try to use the inbuilt function again, it is your function is going to be called, at least in that run. So you have to be careful with that. So types of functions, built-in functions, user-defined functions. Advantages of functions, really, I've mentioned some of them already. Easier to understand, and remember, as coding changes, you only need to update code in one place instead of many places. Avoid repetition, makes the code reusable. Okay, it's 11. Break time. So we'll take a 5-minute break and we'll reconvene, stretch, do exercises, go over what you've learned. Okay, 5 minutes. So I hope we are ready to go for the next Python functions. So when should you write a function? You should consider writing a function whenever you have copied and pasted a block of code more than twice. More than once. Once I have to be copying the code and pasting it again, immediately I just write one function to do it. Or especially, or if it's something that I know I'll still do again, or a code I know that I will need often, right? I'll do it again. So the best thing to do is just write this function. So your function is like something. I'll show us an example. So creating a function. Yeah. So how do we create a function? Let's look through. Basically, your function block starts with the def, right? You have a def, followed by the function name, your parentheses, your argument, your colon. Any parameters or arguments should be placed within these parentheses. You can add as many arguments as you want. Also, the colon must be at the end to serve as the end of that function header, to mark the end of the header. Optional documentation to describe what the function does. One or more valid Python statements to make up the function body. Statements will have the same indentation level. Remember, I said that Jupyter Lab will do this for us automatically. And then the functions may return a value or not using the return statement. This is optional, but for most of the functions we write, it's really important. Okay. So function name, that's describing function docstring, what the function does. List of expressions to be used and a return expression. This is what it usually looks like. Your def keyword add is the function name, function arguments inside your brackets, parentheses, print, the arguments are this, return x plus y. So this is a function to add two numbers. All right, so calling a function in Python. Let's look at what it looks like. Let's create a function to add any two numbers. So sum underscore, so we start with our def keyword, def, and then sum underscore two underscore numbers, that's A, comma B, right? And then you say this function adds two numbers together, that's a docstring saying what the function does. Return A plus B. You see that there's no results, right? So I can anywhere in this code, see this is where we wrote this, right? Anywhere in this code, like literally, I'm going to the bottom. I'm going to the bottom, right? And I can now come here and say sum two numbers. And I can say 3 and 5. So it helps me that anywhere in my code, I can go back and use a function I have written at some points. Right? So that's really the idea. So let's look at another example. And the function is reusable, like I've shown. So this is it, sum two numbers, we get a result. Same thing, another number, we get another result. So you can always write your functions, you can always write them to compute different things, do different things, as long as you need it to be reusable, to be used anywhere in your code, rather than copying and pasting every time. That's prone to errors. All you need to do is write a function and call the function. So check this out now. Remember we wrote a code to find the area of a rectangle, right? One of us remember the quadratic formula, b squared equals to b equals to b, no, I think it's a plus bx into over, we all remember that. No, the quadratic, I mean the minus b plus or minus b squared minus 4 is equal to 20. Thank you. Somebody remembers. I think if we have the time today, that would be a very beautiful one to use, just like that formula to solve any quadratic equation. Okay, so but let's look at so if you remember the formula, so let's write it out so that we can work with that. So let's see. So that we'll use that as our final exercise today. So this we can get an indentation error when you're defining a function if you don't define it properly. For example, check this out. Def sum two numbers, right? But we've stepped outside the def function with this indent here. Do you get? So this is outside the def function. We'll get an indentation error. So what we have to do is just bring it back in and we'll be fine. Okay. So this is the same thing, adding two numbers. And you can have the function return this. So this function adds two numbers together in another form. Print this, the sum of x and y is this. So add 2, 6, you don't know what, the sum of 2 and 6 is 8. Remember our string method, string format method. Okay. You can also say add x is 10, y is 32. It works the same. It works the same. So the print info, age is this, gender is this. Now, if you print info at any time, now this one has, we've set up default values here, right? So default argument is the argument that it will, by default, if we do not put anything in the parentheses, it will still give us, it will still give us your figure and your age is 25. Although we've not put any argument, why? We've set up default arguments. X minus B, yeah, thank you. Thank you, Richard. Okay, so print info will give us that. Now you can change that at any time by resetting, the argument. Age is now 20 and gender is male, or age is 19 at any time. All right, so let's look at another function. The function that prints out the demographic information about age, students taking a particular course. So we have all these details, and this was what we called. Let me show you here. All we have to say is student info, and you put all these variables, the name and everything. Now the good part is all these variables can be in a dictionary, and you call this function on that dictionary, and what's going to happen is to just return all these variables. So we define the function here, print information about the student in this. You see name, age, gender, class, state, class. This underscore is there because class is a Python keyword. All right. So that's that. So I'm just showing us all sorts of examples. You can write a function that takes inputs from a user. So this is a function that checks if the number is an odd number. int input enter a number to check whether it's odd or even. We define our function as odd even checker, right? We have the number here. If the number is what? Even. That is, if the number divided by 2, we return the remainder that is 0. That means it's even. So print number is an even number. Else, if it's not even, it's definitely odd, right? Or is there something that it can be if it's not even? No. So print f, string format, number is an odd number. So let's check this out. Enter a number to check for odd or even. 4 is an even number. And it's not just here. I can take this function and just really say, oh, number here. Right? Where's number? Okay, set up number already. So another thing you can do is, I don't want it to be like this. I want to say odd number checker. And I can see number is now, I'll just take this whole block here. So we want that every time we run the function, it will ask for the number itself. But so we've written it such that now all we have to do is type in the function odd number checker, and the function will ask us to input a number. So odd number, sorry, this is the old one. Okay, so odd number checker now. Please enter a number to check. So we enter 5. 5 is an even number. You can run it again. Enter a number to check. 89. 89 is an odd number. So that's a good number. You see that I'm not rewriting this. It's there, wherever it is in my code. And it can always be used. Okay? Even number checker, Same thing, checks if even else, return even else, return odd. Because this is an if else, only one of these will be returned, right? Okay, we're catching on good. So this is a task taken from data camp, and we have a list of strings, right? And we have lists here, and the idea is just print out each of them. List benefits, it will print out each of them. So for string in strings, print string, you see that all we've done is like saying that we get, this is just a normal for loop, a normal for loop print. But now making it a function means I can call this anywhere in my code. I can get this anywhere in my code. So I don't have to rewrite for string in this, do that. Okay. So we'll look at one example together, and then, so before we look at this class activity, or should we look at, okay, before we look at the class activity, we look at one example together that we've done before. So I think we have a message on the chat. Why is my name not on the attendance sheet? You probably registered late, or you are not searching your name properly. So you can just search, maybe search a few characters of your name, and you should be able to see your name on the attendance sheet. All right. So where were we? Okay. So I want us to use an example we've used before. So let's look at if we needed to calculate the area of a rectangle. We have a rectangle, right? So let's say we're writing a function to calculate the area of a rectangle. The first thing we write is here, and we say let the function be area and length, breadth, and the argument this function will take. That is, every time I call this function, once I supply the arguments length and breadth, the function should return the area for me. So length, breadth, it's automatically indented, thanks to Jupyter. Yay. And we have that. So what's the first thing we do? We know that length, let's ask the user for the length, int, input. Now, let's make sure this actually collects only numbers. And how do we do that? Okay, we can do that. Input, enter the length. So the try and except, the try and except work like if and else. Try to make sure that if there's an error, rather than returning an error, what is in the except part will be run. So I want to use this to make sure that only integers like numbers can be used in this code. So if there's an error, so please enter an integer as the length. So if someone enters something like this, not an integer, that will produce an error here. Rather than stopping our code and saying there's an error, ask the person to enter an integer as the length. Okay, so getting fun now. So then again, let's return that try. I can lump this together. Should we lump it together? Let's see first. So breadth is int, input what, and the string, enter the breadth, and then we have to use the except there to make sure it is so, and then except breadth right is enter an integer as the breadth. All right. Now, all this one we are doing, we've not done any compute. All we are saying is collecting input from the user, right? Yes. Yeah. Okay, so thank you. Okay, that's good. So next thing is our formula, and as we can say, maybe answer or something result is length times breadth. So we have that. The next thing we need to do is return this and return, that is what we want the function to, or be the result of the function, such that I can actually assign the function to a variable. And what the variable will be, the variable is what I specify in this return function. Exactly. So you can use it without parentheses, with parentheses. So return, or let's print first. Even. So print area is so return. All right. Now look at this long lengthy function we have written. All we need to now do is anywhere we feel like, we just come over here and now say area. Let's see. Area, yeah. So let's say area. Let's say length, breadth. Right. Length is not defined. Uh-oh. Oh, that's it. Okay. No, it's just all we have to do is this. But I initialized, but we are not initialized anything here. So area, enter the length. I can now try this. I check if I enter something that is not an integer. Instead of normally it will return an error, right? Now we see what is enter an integer as a length. I try to be funny again, say value error. So this is what it should have entered before. If it didn't enter, this is what it would have shown. But now we're able to catch that. Now we can even now for this way I'm going that you see that the second time it didn't catch the error. What if we set up a while loop and we say, or even maybe yeah, a while loop. So while, because the while loop is going to kind of run forever, but not so. So while the input type is not this, always return this. I don't know if that's clear. Or is it going over our heads? Okay, let's keep it simple. We'll move on. We'll do that later. I've already seen. I'm not liking the response. Yeah. Is that what? Yeah. So I usually try except because we want to make sure that only integers will work, right? But right now, it's not. I've not written it such that it will stable and say that even if, because what we did here, when we entered the length, I said wait. He said no. It says enter an integer as a length. If I enter an integer here, it will go on and go on the area is 12 and the code will be happy everywhere. But if we say something else, like second time, we're going to get an error. So if I add another try and except to this try and except, it will catch it. Yeah, so we can't use if else. So basically, if try and except, because try and except is for errors. So we are trying to catch errors here. We're trying to catch the type error. We can actually specify the type of error, right? But why we are not using if else is we can't say if error. We can't do that. So try and except is specifically for how do you insert the square root in Python. So we already discussed that earlier on. So the operator for your square root is the double asterisk. So this is just a simple function to do something, and just a demonstration of how you can catch errors. Okay, so let's look at the class activity now that you are going to do. This one is really long. Wow. So I want to see how I can reduce. Oh, I don't have any people doing anything, but let's. All right. So this is the class activity. We want to write a function. Okay, square root. Yeah. So sorry. So square root. I'm not sure Python has a square root function. Usually we use numpy for square root. So you import numpy and then you use the numpy square root function, or you import one of these scientific packages and use the square root function. I'm not sure if Python itself has a square root function. I'm not sure. All right, so this is the class work. Let's do this for, I think we can, before we go to class, let's close up on this one. Yeah. Yeah. So I need specific name and then state. So I declared my dictionary first. Okay. Then I started the function. Did you declare a dictionary in the function? No. So what was the error? Type error. Yeah. So, but you defined it, but it's telling you that you are missing the dictionary argument. So what argument do you think you are missing? And from the dictionary, I put name as state. Just put the dictionary as the dictionary object. So why don't you dictionary items, or you call, because you know if you put the dictionary, it's only the keys. Exactly. So you must use maybe a method to extract those. Still missing one. Okay, maybe I'll do the class. I'll walk over to you and we'll see how we do that. Okay, but so here is our class work. So let's take what we have. What's a pattern error? Yeah, this, so please note your AI Plus membership ID is not your student ID. The student ID is on the, please let all, so everyone following online, offline, every detail is on the info pack. Please just try to read through so that you have all the details that you need. But our class work, and we'll stop here for today. And next class, we'll move on, take everything we've learned, let's mash it together and create machine learning models. Okay, so we write a function that asks the user to enter two numbers. The function will print their sum and their difference, each on a single line. Then write a function that prompts the user to enter an integer n and outputs the letter x n times on a single line without a space. So that means, I think we can figure that out now. So write a function to convert the Fahrenheit, a temperature given. Now we're not going to finish all this today, but I'd like us to take each of these home. You can take a screenshot, take a photograph, but let's take each of these home and actually work on them. We'll be closing early today. We'll be closing by 11:45, so we can have time to do some of that in my call to engage us on that. But we're writing a function that will now prompt the user. But right now here in class, please, number one, we are doing number one. Write a function that asks the user to enter two numbers, and this function will print their sum and their difference, each on a single line. And then also you're going to write a function to convert Fahrenheit to Fahrenheit, a temperature given in Celsius. So the formula is there as well, TC, temperature in Celsius. So temperature in Fahrenheit is temperature in Celsius times 1.8, right? Times 1.8 plus 32. So you can convert each of these. So let's start on activity one. Let's do that, 5 minutes. Then move to activity three, another 5 minutes. All right, let's go. Let me take a look at that.
Guys, today we'll do a group picture, please. Don't be the hardest.
All right, let's take a correction. Okay, so let's take a correction on that. All right, so I'm seeing some messages on the chat. Because that's what I have used as mentioned. I just remember. You can't just remember. Anyway, okay, so all right, let's see. Class activity one. Write a function that asks user to enter two numbers. This function will print their sum and their difference, each on a single line. So that's what def our class work. And we need two numbers, called number 1A, called number 2B. And then the first thing we want to do is print their sum on the line. Sum is A plus B, and their difference. Difference is, oh, I can use some added A plus B, difference is A minus B. And then what print their sum is added, print their difference is if return a tuple. I like to return a tuple of the answer added and be such that the first item is added. Of course, they didn't ask us for this, but I think it would be cool, right? But let's just take it out since it's not in the question. So nobody is confused. There's some difference each and a single line. Yeah, this should do. So let's look at it. Classwork 2 and 3. The sum of 2 and 3 is 5. The difference should be 2 minus 3 minus 1. Numero, classwork code, class underscore work. The sum is 5, the difference is minus 1. Is that clear? Is it what? Where? So ask the user to enter. Oh, I'm so sorry. He asked the user to enter. So that means A equals to 90 input. What? Enter number 1. B equals to int right input and then enter number 2. All right, this should work then. All right, let's see. Enter number 1, 5. Enter number 2, 7. The sum is 12. The difference is minus 2. Good. How many of us got it? Any issues with that? No. All right, great. So second one and the third one, please, we're going to drop these two on our classwork, and I'll drop a link to a project as well. I'll set up the project for all of us to do. Don't worry, your project count. The project, of course, it's not going to be graded, but it really help you and help to put all the skills we've learned over the last 3 weeks together. So today you're going to get question 2 and question 3 on the classwork, on the assessment for today, and on the info pack. Then we're also going to get a project that we're going to work on together ahead of maybe upper week or something. So let's see how we can put all that together and do something wonderful. All right, so on that note, I will close with, okay, this is just lambda functions. Since we know functions, we can easily pick that up. So Python libraries, all I'm going to say is the Python library is a collection of Python functions that are written in modules. And once you get to machine learning, everybody will start saying, we need this library, we need that library. So all you need to know is to use a library, a module, you import it using the import keyword. To use an attribute, to use the model name, those attributes. So I can import NumPy, right? It might take a while. I import my NumPy and right, what did it say? Name type check is not well. There's something wrong with this NumPy. So I can say pip Let me install. Let's try that again. So to install a package you don't have, usually you can use pip install or anaconda install. But I don't know why this numpy is not. I think there's something wrong with this guy's numpy. So let me see. Let's go pandas. Import. Oh yeah. So a good example. What is going on? Okay. Let me use this work we did earlier, where we defined where we were talking about the while loop, and we used the Python, IPython display to explain that. We covered a lot today. Yeah, so from IPython.display import layout. So this is an example of importing a package. So this is another module. From this module, I imported this function. So you can also import that way. I can also import IPython.display, and then I can also now say I can now import clear output. Moving on to my copy clear output. So I can now say from IPython.display, but since that repetition, and then you can import a module as anything really. Oh, I know why, because I'm not using simple Jupyter, that's why. Okay, from importing. So from a module, you can import another module and so on. But this is going to be covered again when we get to machine learning. That's the first thing we cover: installing your module, importing your module. Let me see. Okay, so we've not been able to get our NumPy to work. I really like that. I wish that would work. Why not import NumPy as MP? Yeah, you can import pandas. Yeah, it's not you're importing as MP or importing as PD is only to it's just like a short form, right? You can import it as anything really. You can import NumPy as FY, right? But of course there's a convention, but really you can import as anything, and the idea is just like a shorthand. Okay, so there's a question here I want to address. Um, my attempt at quadratic formula, but it's not working. Okay, square root. Yeah, you need. Yeah, I think we can solve that one online class. So this is my membership ID. I signed it. So these have been covered already. So please, it's important to note that your membership ID is different from your student ID, which you will see if you go through the info pack. So I'm not going to cover that again since it's already in the info pack. So please just go over the info pack so we can. How do you write square? So that's it. This is the square root. It's just numpy dot square root. For many of us using Anaconda, we should have numpy installed already. Just type import numpy, right? If you run it, it should run. I don't know why this is having an issue here, but it should run on your end. How many of us is running at your end? Yeah, it should run. One of the advantages of Anaconda is that it comes stored with many of these packages that you use. Okay, so we'll continue online and with updates on the info pack later today on the other things that you need. So we'll end the class here. My colleague will take a group picture, and we'll continue online on WhatsApp, email, and via the info pack. So if you have any questions, please let's engage on WhatsApp, and we'll see how that can be sorted. So we'll see you on Thursday, right? Please, if you're coming on Thursday, do come. I can't hear you. Is this? So if you are using input, most times you just leave don't define your argument since the function will call and ask for the argument. So if you define your argument, by the time you run the function will tell you that you've not defined that argument. And to be burdensome to be defining the arguments inside here and saying A is inbuilt. Okay. So that's let me open and run. It's still basically the same thing. Okay. So thank you all. I will, like I said, we'll engage further on WhatsApp and other platforms. Thank you, Josephine. Who else? Okay. Thank you, Zion. Thank you, everybody. See you next class.